Okay, we're going to add rational expressions. The process we're going to follow involves 4 steps. We're not going to use all of them in this first section. In the second section, yes, we're going to do the process step by step because it's going to be required. In this case, no. Normally, we try to factor the denominators at the beginning, but if there is nothing you can factor, then you're going to leave it like that. Then we're going to have to multiply in order to match the denominators. This is something we're going to do most of the times, and it's kind of like the key step of addition of rational expressions. So it is important to make sure that the denominators match, that they both become equal expressions. And once they are identical, we're just going to have to add the numerators, and if we can simplify the answer, well, that will be something good to do. If there's no need to simplify because it's impossible to simplify, then we're just going to leave it like that. We need to already know how to simplify rational expressions, which means we already need to know how to factor. You need to know how to factor before you try to do any of these exercises. So let's begin. Okay. First exercise is a simple addition. The key in this case is to understand that you cannot add unless the denominators are identical. In this case, they're not. So our goal is to make sure that they match by multiplying. How could you make these two denominators identical by multiplying? Well, you just need to multiply 4 in here. If you multiply by 4, this x will become a 4x, right? Which is the same as the 4x that we have in here. So we're going to be doing a lot of that type of process to make sure that we get identical denominators. So the first fraction, I'm not going to do anything in here. The second fraction, yes, I'm going to multiply it with 4. Every time you decide to multiply in order to change a fraction in its writing pattern, like change the denominator without changing the actual number, you're going to have to multiply up and down. Okay. Every time you multiply with a number, you're going to have to multiply up and down. So the first fraction is going to stay as 5 over 4x. Now the second fraction, if we multiply 3 times 4, it will give us 12. And if we multiply x times 4, it will give us 4x. Now we have the same denominator. If we have the same denominator, all we need to do is add. So 5 plus 12 will give us 17. The denominators, we're not going to add them, we're only copying the denominator, and that's it. That will be the answer of this exercise. Let's do another one. Okay. This case, same idea. We're trying to add, but it is impossible because the denominators are not the same. So we need to make them the same by multiplying. How? Well, the 6 and the 4 are different. But if I multiply this 4 with 3 and this 6 with 2, I will get 12 in both of them. So that will make them equal. Not only that, this one is w squared, but this is a single w. So if I multiply with w in here, that will make w squared. That will be identical to the other one. And also, this one has a y, but this one doesn't have a y. So if I multiply here with y, I will get the y that the other one has. So I have to multiply several stuffs, both numbers and letters. So we're going to try to figure out which numbers to multiply, which letters to multiply with, so that we get the same denominator. The key is you get the same denominator. So in order to get the same denominator, in this case, I'm going to multiply the first fraction with 2 and with w. That way I'm going to get the same 12 in both of them and the w squared that the other fraction has. The second fraction, I'm going to multiply it with 3 and with y. So if I multiply this with 3 and with y, I would make sure that I get the same answer as the answer I'm going to get in the other fraction. So let's try to do this. 5 times 2w is 10w. Now 6wy times 2w is 6 times 2, 12. W times w is w squared, and the y, we just copy it. Plus, on the other fraction, 3 times 3y will give us 9y. The 4 times 3 will give us 12. The w squared, there's nothing to multiply with, so we just copy it. And the y, there's nothing to multiply it, so we just copy it. Notice that now we have the same denominators. That's nice. If we have the same denominators, we just need to add up 10w plus 9y. Because they are not like terms, they have different letters. All I need to do is copy them. So 10w plus 9y. That will be the answer for the addition. At the bottom, I would just copy the denominator. And because I cannot factor here on top so that I can cancel anything, so there's no way we can simplify this. That's already on its simplest form, so we're going to leave it like that. That will be the answer of this exercise 2. Notice that the focus is always try to get the same denominator by multiplying. That's the focus. That's the key process that is going to be done in every single exercise. Let's see this other example. Okay, we need to get the same denominators, but what happens if they are already the same? Then we have something less to worry about. All we need to do is add. So 3b plus negative 5b, right? Because you add like terms, right? Not stuff that are different. So 3b plus minus 5b will be negative 2b. Then 4 plus 6 will be 10. So minus 4b plus 10. What do I do with the denominator? I just copy it. Okay. So I don't need to multiply anything in here because I already have the same denominators. So I don't need to multiply. Remember, we multiply to match the denominators. If they already match, I don't need to multiply. Now, in this case, I can simplify this. This is not the answer because I can factor the numerator, and that is going to allow me to cancel stuffs. If I factor minus 2b plus 10, the answer will be minus 2 times b minus 5. I will see that the minus 2 repeats in both scenarios. Minus 2 is here, and 10 is minus 2 times minus 5. So if I take the minus 2, that will leave me with a minus 5 inside. The denominator is b minus 5, so that one doesn't require to be factored. It's impossible to factor. Now notice that in this case, the b minus 5 is up and also down, so we can cancel it. We're going to do that. That will leave us only with a negative 2 as an answer. And that will be the process that we need to follow in this case. Let's take a look at this one. Okay, we have a minus 2 and we have 2 minus a. On first hand, it will look like if they are different, but they're not exactly different. Okay, 2 minus a, you need to understand that 2 minus a is basically the opposite of a minus 2. I'm going to prove it. Okay, 2 minus a, okay, is the same as negative a plus 2, right? Now, if I decide to factor the minus from this, it will give me negative a minus 2. Now, notice that I have a minus 2 in here, and I have a minus 2 in here. So, instead of writing it like this, we should prefer writing it this way, so that we know what are we missing. So, we're going to do that. Okay. So, we have on the first fraction, 5 over a minus 2. And on the other fraction, we have 3a over negative a minus 2. So, are the denominators identical? Not exactly. The second denominator has a minus. If you think on an invisible number as 1, okay, basically you have a minus 1 multiplying a minus 2. So, that's what I need to multiply with in this case. So, if I multiply the first fraction with negative 1, that would put the minus in the a minus 2, and it will make the denominators identical. If I multiply 5 times negative 1 will be minus 5 divided by the a minus 2 times the minus 1. I'm not going to multiply it. I'm just going to copy the minus of the 1. I'm going to make the 1 invisible, and I'm going to put the a minus 2 inside parentheses. I'm going to leave it without multiplication. That's going to help me to know, or show at least, that now I have the same denominators. Notice that I have the same thing under the line. So now I can add. So I'm going to have to add negative 5 plus 3a. And that will give me 3a minus 5. Because remember, when they're different, when they're not like terms, you just need to copy them. And the denominator, in this case, we're also going to copy it. So it's going to be minus a minus 2. We can multiply in this case, and we will get 3a minus 5 divided by negative a plus 2. And that would serve as a good solution for our exercise. There are other ways to do this thing. We could factor a minus, for example, from the numerator. It will leave us with minus negative 3a plus 5, for example, divided by minus a minus 2. And we could cancel both of the minuses, and that could direct us to a different answer, like minus 3a plus 5 divided by a minus 2. Both of those answers are correct. It doesn't matter if you get one or if you get the other one. They're both correct. So these processes that we use are the first type of processes that we're going to follow in order to add rational expressions. There are other types of rational expressions that when we add them, when we try to add them, we're going to have to do something different, which is going to be seen on part 2.